Good evening. It's 6 o'clock, so we'll go ahead and get started. My name is Gerald, and I'm the community representative for East Bay MUD and the community contact for areas outside of East Bay MUD's service area. So if you have any questions, I'm the go-to person on this project or any East Bay MUD related issues. Tonight, however, we'll be talking about the MARP, the Mokelumne Aqueducts Resiliency Project. So first of all, some housekeeping's in order. We'll have everyone muted. If you have a question, please click on the raise hand function so we can address your question. If you have clarifying questions, please ask those. And if you have questions you want documented in the environmental impact report, please submit those in writing, and we'll go over at the end of the meeting how to do that. This meeting is being recorded tonight, so by speaking, you're agreeing to be recorded. And it will be posted by Monday, April 18th. So with that, we'll keep everyone muted and turn it over to the presenters.
Thanks, Gerald. I'm going to share my screen. Can you see my screen?
Yes.
Okay, so thanks. So for those attending tonight, I want to introduce myself. My name is Bill Majori. I am the senior civil engineer responsible for the planning phase for the Mokelumne Aqueducts Resiliency Project. Here is a photo of East Bay MUD's 3 Mokelumne aqueducts that are the primary supply for 1.4 million people. There are many risks to the reliability of the Mokelumne aqueducts that the project will address to ensure we have a reliable water supply. The purpose of this meeting is for East Bay Municipal Utility District staff to discuss the need for the project, what we are planning to build, explain the public review process, and discuss how we will receive community input. Please note, East Bay Municipal Utility District is also known as East Bay MUD. The detailed agenda for this meeting includes an overview of the project schedule, introduction to the project team from East Bay MUD here tonight. We will explain East Bay MUD's water supply system. We will discuss the need for the project and then explain what we are planning to build. We will go over the environmental process and EIR schedule, and at the very end, there will be time for questions and comments. We are at the beginning of the planning phase, which will continue until 2026. As part of this phase, we will develop the conceptual design, conduct environmental review, and conduct public outreach. After planning is complete in 2026, we will immediately design the project and obtain any necessary permits, and that is expected to be complete in 2031. The construction phase has not been firmly established, but is tentatively scheduled to begin in 2031, and construction would take approximately 3 years. Again, my name is Bill Majori. I am the senior civil engineer, and I report to David Renstrom, the manager of East Bay MUD's planning division, who is here tonight. Also with us tonight is senior civil engineer Marshall McLeod, who is responsible for the design of the project, who will co-present with me tonight. And he reports to division manager of pipeline design, Carlton Chan, who is also here. And then we are also assisted by Gerald Schwartz, who you've heard from Community Affairs, and we also have consultants helping us on the project, WSP, who is preparing the conceptual design, and Panorama Environmental, who is conducting the preliminary environmental review for the project. To understand the need and details behind the project, I'll explain a bit how East Bay MUD's water system works. So this figure shows East Bay MUD's water supply system, which I'm going to walk you through. The scale of this map shows the East Bay MUD service area on the left, which over here, which is on the east side of San Francisco Bay, and on the right side of the map is the Sierra Nevada mountains. East Bay MUD gets 90% of its water supply from runoff from the Mokelumne River watershed. And the runoff is collected and temporarily stored in Pardee Reservoir and Comanche Reservoir near Jackson, California. Comanche Reservoir provides downstream flows in the lower Mokelumne River for fishery, downstream diverters, and flows into the Delta, as well as provides flood control, power generation, and recreation. EBMUD's water supply is delivered from Party Reservoir through the outlet tower shown in the photo. During droughts, EBMUD also delivers water from the Sacramento River through the Sacramento River Freeport intake shown in the photo. From the Freeport intake, water is delivered to EBMUD's water supply system near Comanche Reservoir through a series of pipelines, pumping plants, and the Folsom South Canal. This system is shown in yellow. The 90-mile-long Mokelumne Aqueduct system delivers water supplies from Party Reservoir and the Sacramento River to our service area. The aqueducts are 3 large diameter steel pipelines ranging in diameter from 65 inches to 88 inches, a portion of which is buried and a portion of which is elevated above ground as shown in the photo on the screen. When it reaches our service area, water is either temporarily stored in one of our local reservoirs or immediately treated at one of our 6 water treatment plants before being distributed to our 1.4 million customers located in 29 cities and 17 unincorporated communities in Alameda and Contra Costa counties. This is a photo of our Walnut Creek water treatment plant on the east part of our service area. Now, the Mokelumne Aqueducts Resiliency project that we are here tonight to discuss would be located in the vicinity of the Sacramento-San Joaquin Delta, as shown in the figure here. And now I'm going to hand the presentation over to Marshall McLeod, who is responsible for the design, and he's going to discuss the location, the need for the project, and the project details.
Okay, thank you, Bill. Yeah, my name is Marshall McLeod, and I'm the Senior Civil Engineer managing the design phase of this project. Next slide, please. This slide shows the alignment of the Mokelumne Aqueducts within the Delta. The Mokelumne Aqueducts, rather, are 90 miles long, and of this, 16 miles are crossing the Delta. The Mokelumne Aqueducts are 3 large steel pipelines shown in gray where they are buried, and in blue where they are installed above ground on pile-supported vents, distance of about 10 miles. They are installed above ground due to the unstable soils in the Delta. There are also 3 underwater river crossings shown here for the Old, Middle, and San Joaquin rivers. Now, what is the Delta? The Delta is a system of low-lying tracts of agricultural land surrounded by rivers and channels. The land is protected from the water by levees. Beginning about 150 years ago, these levees were built by farmers to prevent flooding and to reclaim the fertile farmland. They are constructed of native soils by construction methods of the time, such as clamshell dredging and manual methods. While these native soils are excellent for agriculture, they do not provide good materials for levee barriers meant to continuously contain water. The Delta has over 1,000 miles of levees. The perimeter levees protecting the Mokelumne Aqueducts are shown here on this map with a dotted orange line. Next slide, please. The light brown shading highlights the project location. Next slide, please. This slide shows the existing conditions. The left cross section shows the aqueducts where they are buried from Stockton to Holt. The right cross section shows the aqueducts where they are installed above ground from Holt to Bixler. The most vulnerable aqueduct is Mokelumne No. 1, built in the 1920s. However, Mokelumne No. 2, constructed in the 1940s, is also showing signs of age in the Delta. Mokelumne 3 was built in the 1960s, and seismic upgrades were completed in 2005 within the Delta. Next slide, please. So now I'm going to present the need for the project. Next slide, please. In the Delta, we have aging pipelines protected by aging levees. The aqueducts are vulnerable to damage from both flooding and earthquake hazards. There are small earthquake faults in the Delta, but the largest seismic sources are the large faults to the west, such as the Hayward and Calaveras faults. I'm going to present some of the flood and earthquake hazards to these critical pipelines in the Delta, and then present how this project will mitigate the risk. Next slide, please. The oldest of the aqueducts is Mokelumne number 1, which is approaching 100 years old. It is interesting to note from these old construction photos that the joints are riveted steel. Modern steel pipe joints are typically welded. In the right-hand photo, also note that the ground surface is very close to the pipe support saddles. Next slide, please. The previous photos are a stark contrast to the current conditions. Ground surface has subsided over 8 feet within the aqueduct alignment in the delta. Ground subsidence is a direct result of farming activities which oxidize the thick layer of peat soils in the delta and increase compaction and wind erosion. This ground subsidence is causing pile degradation and differential settlement, which is in turn causing damage to the pipelines. Also, the loss of lateral support on the piles makes them more vulnerable during an earthquake. For Mokelumne number 1, we have only replaced 4 out of the 50 temperature anchor structures, which are settling due to pile degradation. A temperature anchor is shown in the upper right photo. In addition to the temperature anchors, there are also over 1,700 support vents that are also degrading. Next slide, please. In addition to the peat soils in the delta, we also have loose sand deposits that are susceptible to liquefaction during an earthquake. The pipeline and supports are vulnerable to damage from the resulting liquefaction-induced ground settlement. This photo shows liquefaction damage after an earthquake in Japan. Next slide, please. Of greater concern is the impact of liquefaction on our aging perimeter levees. Levees are susceptible to lateral spreading when the underlying soils liquefy. Numerous locations of lateral spreading could result in widespread flooding in the delta. Next slide, please. Now, absent of earthquakes or overtopping flood events, the levees in the delta are still vulnerable to failure, as demonstrated in 1980 and 2004 sunny day failures. The photo on the left shows the impact of the 1980 event when a levee failed on Lower Jones Tract. The flood water caused the railroad embankment in the lower portion of the photo to fail. The Mokelumne Aqueducts are shown in the upper part of the photo parallel to the railroad tracks. This was a close call that nearly took all 3 pipelines out of service. The photo on the right shows levee repair activities at the 2004 breach location on Upper Jones Tract. Next slide, please. Now, these levee failures cause large scour holes due to the erosive force of the incoming floodwater. The photo on the left was taken after the levee repair was completed and the island dewatered after the 2004 event. This scour hole measured approximately 2,000 feet long and 80 feet deep. The scour depth is well below the depth of the pile foundations of all 3 aqueducts, and this would have taken all 3 pipelines out of service had the breach occurred closer to the alignment. Instead, all 3 pipelines were submerged, as you see in the right-hand photo. Our pipelines were not designed for submerged service. They were vulnerable to damage from wave action, floating debris, buoyancy if they happen to be drained for maintenance, and corrosion. All 3 pipelines had to be recoated after the 2004 event due to corrosion damage. Next slide, please. Now I'm going to describe the conceptual design of the Mokelumne Aqueducts Resiliency project. Next slide, please. In order to avoid the flood and earthquake hazards at the surface, EBMUD plans to construct a deep tunnel within the EBMUD right-of-way. This tunnel will be approximately 16.5 miles long with a welded steel carrier pipeline inside, sized for the full design flow capacity. We will also remove it or abandon Mokelumne Aqueducts number 1 and 2 within the delta, and we will upgrade and maintain Mokelumne Aqueduct number 3 for operational flexibility and tunnel outages. The proposed tunnel will be approximately 100 feet deep and the bore diameter will be approximately 15 feet. The cross-section on the left shows the proposed design for the buried portion of the alignment between Stockton and Holt. Mokelumne Aqueducts 1 and 2 buried pipelines will be abandoned in place and filled with grout to prevent future collapse hazards. Mokelumne number 3 will remain in service, and the deep tunnel is located below these pipelines, within the East Bay Mud right-of-way. The cross-section on the right shows the proposed design for the portion of the alignment where the existing aqueducts are installed above ground on pile-supported vents. Mokelumne number 1 and 2 will be demolished and removed. The existing piles will be cut off approximately 5 feet below the ground surface and abandoned in place. Mokelumne number 3 will remain in service above ground. The deep tunnel is located below the pile supports within the East Bay Mud right-of-way. Next slide, please. Now the tunnel will be installed in soft ground by a tunnel boring machine, or TBM. As the TBM advances, the TBM will erect precast concrete segments to form a ring for initial ground support, as shown in the photo on the left. In our case, because the pressure is relatively high from Pardee Reservoir, we will also be installing a 120-inch welded steel carrier pipeline inside. The lower right photo shows a similar installation by SFPUC under the San Francisco Bay. Next slide, please. Now, in order to construct the tunnel by TBM, we'll be installing 4 temporary construction shafts. These will be located in Stockton, Holt, West Jones Tract, and Bixler. Advance the animation, please. Now, there are 2 types of tunnel construction shafts. The launch shaft is where the TBM is lowered down to the design elevation. As the TBM advances, precast concrete segments are lowered down to be brought to the machine for installation. Simultaneously, excavated earth is conveyed from the front of the TBM and brought back to the launch shaft for removal and disposal. Therefore, the launch shafts are the sites with the most construction activities and truck traffic. After completion of the approximately 5-mile-long drives, the TBMs are removed at the reception shafts. The red arrows show the direction of the TBM drives. The main construction activities at the reception shafts are lifting and removal of the TBM, and then welded steel pipeline work to connect the new carrier pipeline to the existing aqueducts on either side of the delta. Next slide, please. The photo on the left shows a typical shaft construction in progress. The photo on the right shows a typical launch shaft in operation. The shafts are typically round, but they could be rectangular. The approximate anticipated dimensions are 60-foot diameter launch shafts and 30-foot diameter reception shafts. Next slide, please. Now, the photo on the left shows typical staging operations of the precast concrete tunnel segments near a launch shaft. The upper right photo shows excavated material leaving the screw conveyor of a TBM, which will be deposited in a muck car or a conveyor belt to be brought back to the launch shaft for disposal. The lower right photo shows soil management activities near a launch shaft. Next slide, please. This aerial photo shows the location of the Holt launch shaft. After completing the tunnel, the permanent feature will be an access shaft for long-term maintenance activities such as inspections. Next slide, please. Similar to the Holt site, this aerial photo shows the location of the West Jones Tract launch shaft, which will also have a permanent access shaft after completion of the tunnel construction. Next slide, please. As previously discussed, the reception shafts will be smaller and will have less construction activities. For the Bixler and Stockton reception shafts, the TBM will be removed at the completion of the drive, and then the new welded steel carrier pipeline will be connected to the existing 3 Mokelumne aqueducts with buried steel pipes and valves. The photo here shows a typical TBM being lifted. Next slide, please. So this aerial photo shows the location of the Bixler reception shaft, which will also have a permanent access shaft after the completion of the tunnel construction, as well as buried welded steel pipelines and valves. This site is completely contained within the East Bay Mud Bixler Maintenance Yard property. Next slide, please. This aerial photo shows the location of the Stockton reception shaft, which will also have a permanent access shaft after completion of the tunnel construction, as well as buried welded steel pipelines and valves. This site is completely contained within East Bay Mud property. You can see from this photo that Interstate Highway 5 is located east of the site, and this property is also adjacent to a school to the south and apartment buildings to the north. Next slide, please. Now I will return the mic to my colleague, Bill Majori. Thanks for your attention.
Thanks, Marshall. So now I'm going to go over the environmental impact report process and schedule. Please note an environmental impact report is also known as the EIR, so we may use that term interchangeably. What exactly is an EIR? Well, the purpose of an EIR is to inform the public of the environmental consequences of a project. Agencies are required to prepare an EIR if there are potential environmental impacts to the community or environment as a result of the project. Based on an initial study prepared for the project, the environmental categories listed here on the slide will be reviewed as part of the EIR. Please see the initial study document for more information, which is published on our webpage. It's a 65-page document that goes into a lot of details about the project description and each of the environmental factors in case you want to learn more about what we plan to review as part of the EIR. So where are we on the schedule? As I previously mentioned, we are at the beginning of the planning phase, where we recently prepared the project description that Marshall just discussed. On March 28th, we published the NOP, which is short for the Notice of Preparation, to provide public notice that East Bay Mud is preparing an EIR for the project. The goal of the NOP is to receive comments on the EIR scope over the course of 30 days. We are in the middle of the 30-day NOP period. Here we are on April 14th, having our first community meeting, and we are here to receive public input on the scoping of the EIR in our project. Moving ahead to the winter of 2024-2025, we will be publishing the draft EIR, and that's when we will hold additional public meetings to describe the findings of the draft EIR and to get additional input on the project. Again, we are in the early stage of the project now, and things are very conceptual. Over the next 2.5 to 3 years, we will be developing more concrete detail on the project and its effects. And we will share those in future public meetings. Based on the comments we receive in response to the draft EIR and those meetings, we will finalize the EIR in the following year. And we will present that to East Bay Mud's board of directors for their consideration. If all goes well, the board will approve the project and we will move into the design phase, which should take place over the course of 3 to 4 years. As I mentioned before, the construction phase is tentatively scheduled to follow and last 3 years. So what are we going to do next? We are going to collect all the comments we receive here tonight and consider them as we further develop the project and prepare the environmental impact report. We will prepare a more detailed conceptual design for the project. We will perform additional outreach to stakeholder agencies and property owners that we may want to acquire temporary or permanent property from. We will then perform environmental studies, including activities like noise, traffic, biological, air quality studies to gather data to be used in support of the preparation of the EIR. Then we will prepare the draft EIR and release it for public review in the winter 2024-25. Now we're going to discuss how to get your questions answered or provide comments. So first of all, thank you very much for your time. If you want more technical information, you can go to this website shown on the screen. It's www.ebmud.com/MARP or MARP for short. I have posted the initial study, which I talked about earlier, which provides some initial analysis on the environmental effects of the project. Also included is the notice of preparation letter that was sent to public agencies, which includes some site figures. And then within a couple of days, I will post this presentation, the slides, as well as the video to the webpage. Now, your comments are important and will help us prepare an EIR that addresses your issues and concerns. So we be sure to plan this important project to minimize environmental and community impacts. We will have a questions and comments session shortly, but if you want your comments and questions documented in the appendix of the EIR, you need to send them to us in writing. Send them to the email address shown on the screen, or if you prefer, you can send them by US mail to David Renstrom at the address shown. But we need to get them by April 28th. Last but not least, if you have any general questions or comments about East Bay MUD that's not related to the project, you can always reach out to Gerald Schwartz, your community affairs representative, at the email on the screen. I'm going to hold here for a few more seconds before I change slides, but we can come back to this slide at the end. If you have to leave the presentation before the questions and comments period is over, you may want to write down the website if you write anything down, and it's www.ebmud.com/mark. So with that, we'll be taking questions and comments, and I will turn over the presentation to Gerald, who will moderate the questions and comments part of the presentation.
Thank you, Bill and Marshall. So are there any questions out there? You can raise your hand. Any questions?
I see a question from Kristen. Gerald?
Yep.
Hi, thank you. This is Kirsten Pringle with the Delta Protection Commission. I just have two clarifying questions. The first, I was wondering if you could clarify how much permanent right-of-way is going to be acquired and how that land will be used. In the initial study, I saw that it says, I believe it was 2.9 acres total of permanent right-of-way will be required for the access shaft. And I know there's a bunch of temporary right-of-way too. But in the agriculture and forestry section, it says that the area required for tunnel access permanently during operation would be less, it's like less than an acre, like pretty de minimis. So I was just wondering, like I said, 2.9 permanent, but it's then less than that. Is the remaining land just not going to be used for access in the permanent right away?
Yeah, I'll tackle that question. I'd say right now the numbers are pretty preliminary. So I would call it 1 to 2 acres of permanent property at each of the West Jones track site and the Holt site. And that property would be, as you mentioned, it'd be needed for permanent access to the shaft as well as for the alignment of the tunnel, which for a short piece is outside of our existing property. And then there's about 10 acres at each site roughly. And like we'll sharpen our pencil later on that later. And it's for temporary storage. And I don't know if you recall, Marshall had a bunch of photos of these soil, stockpiling soil. And then there was these concrete rings that we bring in to help build the tunnel, and all that stuff gets stored there along with equipment and personnel. So that's what that 10 acres is.
Okay.
So the idea is it would be restored at the end.
Okay. So there'll only be a little bit of loss of land use change during operation.
Correct. Yeah. It would be that 1 to 2 acres roughly at each of those two sites.
Okay.
Yeah.
Thank you. And you kind of touched on this in your response, but could you talk about what would be done with the soils? And I understand that's in the preliminary phase, so you may not be able to answer this, but what would be done with the soils that would be excavated? It says in the initial study that it would be dried out and then transported to another facility. Is there a plan of what would be done after it's all dried out?
Yeah, we don't have a plan right now, but it's 10 years out in the future. I mean, I think that kind of the default would be to send it to a landfill, but there may be some beneficial use somewhere that we could, to work out as we get closer to schedule of the project, but I think it's a little uncertain where exactly it will go.
Okay.
Thanks, Kristen. Are there other questions? Going once, going twice. Well, thank you for your participation. If there are any more questions, please raise your hand at this point. If you have formal comments, we encourage you to send those in, ebmud.com/MARP. I don't know if you want to put the other slide back up that has information on it. And again, the recording of this meeting will be posted April 18th on Monday. And Bill, do you have other comments, or Marshall?
I just put the slide up. No, I just want to thank everybody for coming tonight. I saw we have some attendance here, and you know, we welcome input into this project, and yeah, just thanks everybody made time for tonight.
Thank you very much. Appreciate it.
Okay, I'm going to end the meeting now.
Thanks, Mona.
Thank
Sure.
you.
Thank you, everyone.
Yes,
Thank
thanks,
you.
everyone.
Thanks.
Thanks for attending.